Well, good morning. How are we doing today? Good. I had meant to be over in Kingsport today, so I apologize. I did not make it over today. I had some other circumstances that prevented me from being able to get there this morning. So I do plan to come over there at some point, and I guess it'll be a surprise now, right? So it'll just be a surprise. One day I'll be in Kingsport. So I want to remind everybody, Thursday we are having a test. So we will have our test this Thursday over most of Chapter 7, 7.1 to 7.6. Okay, so we're all aware of that, I think, and we're going to finish up some loose ends that we've left today and see what questions you have regarding things for the test. Does anybody have any questions right now about the test as far as the, I guess, how it's going to be or something? Now, I've already told you that on D2L there's a trig identity sheet, trig formula sheet, I think it's called, and I will be giving you that when you take the test along with the blank unit circle, okay? So you'll have that. The formulas that are on that formula sheet are the sum and difference formulas and the double and half angle formulas, okay? So that, take a look at it. Sometimes you'll kind of know what you're getting, all right? It's on your D2L under handouts. Okay, let's go back then into section 7.6. I think that's where we left off. We talked about the double and half angle formulas, and so I'd like to know how you did with those. Okay. Let me get to the right page here. I don't think I'm not there yet, but I'll be there. Over on page 491. Over on page 491, we were looking at those double and half angle formulas. We said that there are formulas that we use to give us the exact value for various trig functions for angles that maybe we're not as sure about here. So does anybody have one you wanted to ask about that you tried first? I'll give you a chance there. Yeah, go ahead.
Number 17.
Okay, over here it's number 17 on page 491. Okay. 17 says the tangent of theta is -3 and the sine of theta is less than 0. Okay, so tangent theta is -3, sine is less than 0, and we've got 4 parts here. We'll just try to go through all this one and check the parts. I guess unless you had a specific part you wanted.
No, I think it's...
Okay, let's just go through this and kind of see what we had. So we're wanting the sine and the cosine of the double angle and the sine and the cosine of the half angles here is what we're looking for. Now, first thing, let's see where this angle is located and what's going on with it. Any information we can find out about it. We know the tangent's negative, and we know the sine's negative. The tangent's negative, and the sine's negative. Which quadrant must we be in? Which one? 4, right, quadrant 4. The tangent and the sine are both negative. So let me draw a reference angle down here in 4. We know the tangent is equal to -3. We know tangent is y over x. Okay, so y must be -3, and x is?
1.
Yeah, just 1, right. We're trying to work with, first thing here, the sine of 2 theta, which is equal to 2 sine theta cosine theta. So we're going to need to find out what the sine and the cosine of the angle theta are equal to. Okay, what the sine and the cosine are equal to. So we need to know that r value. So x squared plus y squared equals r squared. Okay. So now we have 1 plus 9 is r squared. R squared is 10. So the square root of 10 is r. We got that so we can figure out what the sine and cosine of theta would be. So the sine of theta is going to be y over r, and the cosine of theta will be x over r. And we should probably go ahead and rationalize those. We've been doing some rationalizing here. So we're multiplying by square root of 10 over square root of 10. And that gives us negative 3 square root of 10. I didn't leave enough space. Over 10. That's what's going in there. Negative 3 square root of 10 over 10. Okay. And the cosine, then when we rationalize, will be square root of 10 over 10. So we'll want to multiply that out. What are we going to get when we multiply that out? It's going to be negative. Negative what? Are you going to cancel or are you going to just multiply? What are you going to do? Okay, just negative 6. Well, it looks like, let's see, we've got negative 6, but then we've got a square root of 10 times square root of 10, which is 10, right? Down here we've got 10 times 10. Okay, that's what we've actually got. So what are we going to do? Okay, so you're canceling there, so you've got negative 6/10, but that is equivalent to negative 3/5. Okay, so we did want to reduce it down there. Does anybody have a question on the sine of 2 theta, the sine of the double angle? Well, Paul, we've got the information here. Let's see if we can do the cosine of 2 theta. We have three formulas to choose from for that one. As long as we already have the sine and the cosine, I'm going to recommend we just go ahead and go with that first one we looked at that says cosine squared theta minus sine squared theta. I think overall you'll like that one better. Just my thoughts. You can practice with the others and see, but that's just what I think, okay? So it says cosine squared theta minus sine squared theta. And so we get the cosine was square root of 10 over 10 squared minus negative 3 square root of 10 over 10 squared. So what do I get when I square root of 10 over 10?
10 over 100, which is 1/10.
Okay. 10 over 100. I'm just going to leave it right now because I don't know if I want to reduce it or not since I'm going to have to subtract. Let's check out our denominators here and see what we want to do. Minus, what's this one going to be?
90 over 100.
Good, 90 over 100. That's correct. Because negative 3 squared is 9. Square root of 10 squared is 10. So we've got 9 times 10 is 90 over 100. That's negative 80 over 100, which will be, what? 4/5. Negative 4/5. Good. Any questions there on the double angle formulas? Anything on those double angles? The use of the formulas. I'll give you the formulas, but you've got to be able to use them, okay? Let's look at the half angles then for this one. All right, so we've got to keep some of this information in mind. Y'all got it jotted down there, right? So you can tell me what I need to know on it. On the half angle formulas, basically, I'm just going to need to know that the cosine of theta was square root of 10 over 10. So let's go over here and look at the half angles. First one on part C is the sine of theta over 2. Formula for that, plus or minus the square root of 1 minus cosine theta over 2. Half angle formulas were in your book over on page 488. So what did we know again? Let's look back. What did we know? We knew we were in quadrant 4, right? We knew that. We knew we were in quadrant 4. So where is the half angle going to be located?
In the last half of quadrant 2.
Okay, so in quadrant 2. Okay. If your angle theta is in quadrant 4, okay, quadrant 4, that puts you between, maybe we want to put it this way, 3/2 pi and 2 pi. And if we want to know where the half angle is, we have to divide those by 2. So now we get 3 pi fourths is less than pi halves is less than pi. Okay, so we started out with this angle here, theta, being in the 4th quadrant, but we end up with the half angle being in the 2nd quadrant. Okay. Just a little side note to kind of show, how we can get there if we're not sure. Label what the places are. You can do it with degrees also if you wanted. We could have said, likewise here, in quadrant 4, we're between 270 and 360 degrees. If you take half of all those, 270 divided by 2 is what? 135. Half of 360. See how that puts you in quadrant 2? When you go to the half of that angle, okay? All right, so let's go up here. If we're going to be in quadrant 2, the reason we're looking at that, the whole idea behind that is if we're doing the sine of the half angle and we know we're in quadrant 2, then the sine should be positive or negative. It should be positive in quadrant 2. That's correct. So we have to decide on this formula, on these half angle formulas, we have to make a decision as to what the sine of the trig function will be. All right, so we're going to have 1 minus the cosine of theta. Let me go back here and get that from the other screen. Cosine of theta was over here, and it was square root of 10 over 10, okay? And it's over 2. All that stuff's under the radical, but with our fraction, in order to simplify and get rid of the extra denominator in there, what can we multiply it all by? The least common denominator, which is 10. So it looks like we get the square root of 10 minus the square root of 10 over 20. Well, that means the square root of 10 minus the square root of 10 over the square root of 20. Square root of 20, what about that one? 20 is 4 times 5, so what's it going to be? Go ahead. I did that 2 times 10 right there. And got 20. But everything's under the radical here, when I'm right here at this part. Everything's under the radical, so now I'm splitting it apart, okay? The square root of the numerator and the square root of the denominator.
2 square root of 5.
2 square root of 5, right. Okay, yeah, I was going to ask the question again, but thank you. Okay, 2 square root of 5 was what I was looking for there with the square root of 20. Because the square root of 4 is 2, square root of 5 we can't do. And typically this would be rationalized because it has that single radical in the denominator there. That's going to be a little crazy maybe. But we would multiply by the square root of 5 over the square root of 5. And we would get square root of 5 times 10 minus the square root of 10 over 2 times 5, which is 10. So you could leave it that way, or you might say the square root of 50 minus 5 square roots of 10 over 10. Now that 10 in the denominator is not under the radical. Okay, the 10 in the denominator is not under the radical. All right, see where you have a question there. I have a feeling there's going to be a question, and I need to walk over here, I think, and show you something. So let me figure out my clip on here. And I'll do that. I think I know there's a question here, okay? Can y'all hear me okay? Everybody hear me? Okay. Right in here, when we're doing this part right here, it gets a little crazy, right? This part gets a little crazy. Now, if you recall, if you have something like the square root of 2 times the square root of 3, we can say that's the square root of 2 times 3. Okay? That's what we're doing here. So when we would just get the square root of 6 for that one. Here we've got, where were we? Right here. Square root of 10, that's 10 minus. That doesn't look like a minus. I'll have to fix that. Square root of 10 minus the square root of 10 times the square root of 5. So we're multiplying, that's not a word. We're multiplying this stuff here by this 5 here, because they're all under this radical. Now what makes this kind of tricky is we have this other radical here also. That makes it a little strange. But what we're actually doing is right here, we have this times that, because they're all under the single radical, okay? Does that help on that part? Because I saw some looks at that part there. Any other questions on this this part here? This was the sine of the half angle. Okay, let's look at the cosine of the half angle. What's going to change on the cosine of the half angle? In the formula, instead of a minus sign in the formula, we'll have a plus. That's one change. Also, we're noticing that, remember, the half angle's in quadrant 2. So that meant that its sine would be positive. What about its cosine? It'll be negative, right? So we've got to choose the negative on that part. So part D, the cosine of theta over 2, formula says plus or minus the square root of 1 plus cosine theta over 2. We know that theta over 2 is in quadrant 2, making the cosine negative. So we'll have the cosine of the half angle negative square root of 1 plus whatever the cosine was. What was the cosine?
Square root of 10 over 10.
Square root of 10 over 10. Thank you. And other than that, it's going to go the same route as the one we just did. We're going to multiply by 10. The reason we're multiplying by 10 there is to clear out that fraction. Okay, we want to clear that thing out a little bit so that we don't have so many fractions within a fraction. So we'll have negative square root of 10 plus the square root of 10 over 20. Now it's looking a lot like what we had before, so it's negative square root of 10 plus the square root of 10 over the square root of 20. When I do that, I'm just separating that numerator part from the denominator and saying since it's a square root of a fraction, we'll do the square root of both parts, okay? All right, then we'll simplify that square root of 20. We already did it on the other page, so that part doesn't change. It's still 2 square roots of 5. We will multiply by the square root of 5 or square root of 5, which gives us the square root of 5 times 10 plus the square root of 10 over 10. That's what we get there, okay? So like on the test, go as far as you can, okay? Go as far as you can. Yes, I'm giving partial credit, okay? It is stuff you're working out. Show me your work. I will definitely want to see your work. Yeah, it takes me longer, but I need to see your work, okay? So what changed on this one from the sign?
Negative on the
Outside?
and it's
Negative
also
on the outside, right?
positive on the inside for
Positive on the inside, right. Positive on the inside because of the change in the formula, negative on the outside because of where it would be located, right? All right, well, there was 4 formulas right there. Questions on that part? Yes. Where did the 10 on the bottom come from? Okay. 10 on the bottom comes from here. We've got 2. We've got square root of 5 times square root of 5, which is technically the square root of 25, but that's just 5. So we've got 2 times 5. This 2 times that 5. Okay? That's what we get. Okay? All right, what else there? Anything else on that part? Or on anything on this first question, any of the 4 parts there? Well, let's try something else with that. Somebody have another one there you want to look at?
Can you do number 23?
Yes, let's do 23. 23 says cosine of 165 degrees. Okay, this one's one where we're saying, all right, 165, where is that? Maybe we could add something together and get that. That's possible. But we're in this section on the double and half angle, so let's see what we can work with. In fact, this part here said to use the half angles. So if this is half of some angle, what angle is it half of? If I multiply 165 by 2, what do I get?
330.
330. Okay. So this is the same as the cosine of 330 degrees divided by 2. Now let me write up here the cosine of alpha over 2 is equal to plus or minus the square root of 1 plus cosine alpha over 2. That's the formula we're looking at there. Okay, because we're doing the cosine of an angle that is half of an angle we know about. We know about the 330 angle, right? 330 degrees. So we're going to write this out then as this. The cosine of 165 degrees, we said, is equal to the cosine of 330 degrees over 2, which will be equal to, will the cosine of 165 degrees be positive or negative? You know actually where 165 degrees would end. So will the cosine be positive or negative?
Be negative.
It'll be negative because 165 degrees ends where?
Quadrant 2.
Quadrant 2. Okay. All right, so we're going to have negative square root of 1 plus the cosine of alpha. Which one's alpha?
330.
Yeah, that 330 degrees over 2. So we're going to have 1 plus something over 2. 330 degrees is that angle that, ends just 30 degrees before 360 degrees. We want the cosine of 330 degrees. What's that going to be?
11 pi 6.
Okay, 11 pi 6 is another name for the angle, but what's the cosine of the angle? Square root of 3 over 2. Good. So 330 degrees is a known angle off of our unit circle. Okay. So we have negative. I don't know. What do you want to do with this? Maybe before I even write over here, maybe you want to get rid of the fractions inside there like we've been doing. We can do that. Do you want to do that? Multiply by 2?
Sure.
It's kind of like, sure, why not, right? So we'll go ahead and do that. We'll multiply by 2, and that's to clear out the fraction. That leaves us with 2 plus the square root of 3 over 4. And then this is where we took the root of the numerator and the root of the denominator. We have the square root, whoops, it's negative. 2 plus the square root of 3 over the square root of 4, which is 2. So there's what we're getting for the exact value of the cosine of 165 degrees. Questions?
So you're allowed to keep the radical underneath the radical.
Yes, you can keep the radical underneath the radical for exact values. Yeah, we would need to do that here. Here's a way you can kind of test it. You know, some of you like to mess with your calculator. So if you're messing with your calculator, you can put in the cosine of 165 degrees, see what you get, and then come down here and put all this stuff in your calculator, negative, and then the square root of all that, and then divide it by 2 and see if you get the same thing. Okay? It should be. What else from this section on double and half angles? Anything else from that part? All right, I had given you some review problems as well. I don't know if y'all started on those over the weekend or not. I hope that you might have. Let's look at some of those. They were over in the chapter review on page, I have to find them. Starting on 499, right? So going through these just a little bit, just to see what we've done so far, let me kind of pick and choose a little bit. If you have a question, please do ask. I'm over on page 499 a minute.
Possibly do like one of each section.
Well, I can try. I can try to do one of each section, so we'll see how it works out, okay? That's kind of my goal here, but we'll see how it goes. First off, when we started out in this chapter, we started just talking about inverse functions. We had 2 sections on the inverse functions, in fact. And in the first one, we were just getting the idea of what those meant. And we saw that when we have the inverse function, we're being asked what angle has a particular value given for that trig function that's listed. So if I have the inverse cosine of 0, then what am I looking for?
The angle whose cosine is 0.
Yeah, when the angle's cosine is 0. Which angle has that cosine of 0? So which angle is that? Pi halves. It's pi halves. We talked about how there may be other angles that also have a cosine of 0, right? But the inverse functions were defined in certain intervals. Where was the inverse cosine defined?
Cosine is defined from 0 to pi.
Right, 0 to pi. So whatever we answer there for what angle has a cosine of 0 has to be between 0 and pi. Okay, it must be between 0 and pi. With that in mind, if you recall, when we had the drawing up here, and we said, okay, we've got 0, pi halves, pi. And down here, I'm going to put negative pi halves because that's how we use it to define on the inverse functions. But the inverse cosine, we said, is from 0 to pi, so it's in these 2 quadrants. Inverse sine was from negative pi halves to positive pi halves. Inverse tangent is also negative pi halves to positive pi halves. Inverse cotangent, though, is a little different. It was from 0 to pi. It did not follow suit with the inverse tangent. Inverse secant was in quadrant 1 and quadrant 2. And inverse cosecant joins these down here. So all of these we're looking at, if we're just starting out with a inverse function question, they're all either like going to be 0 to pi or negative pi halves to pi halves. We just have to look and see, you know, which trig function it is.
Is it basically based on whichever value's on top of the fraction, like the y or the x?
Is it based on whichever value is on top of the fraction? No, actually the reason that they're defined in certain places is just because they were taken out of their context of the full graph, because the full graph was not a one-to-one function. And when we talk about inverses, we talk about using one-to-one functions to get there. Okay, that's where that came from. What else on this part so far? Let's put up another one for the inverse trig. Inverse cotangent, -1. Inverse cotangent's only defined from 0 to pi. We want where the cotangent's equal to -1, which would also mean the tangent's equal to -1, right? Maybe we're used to thinking more about the tangent. If the inverse cotangent's -1, inverse tangent is also -1. Go ahead.
Be a negative 2 times 2 square root of 2 over 2 times square root of 2.
Okay, so it's where that happens. It's where we have those coordinates of square root of 2 over 2 and square root of 2 over 2, where one of them's negative and one's positive. So where's that going to happen? At 3 pi fourths. Anywhere else? It does happen somewhere else, but, not at pi. No, we're talking about where the coordinates would be the same, so that the tangent and cotangent would turn out to some form of 1. -1, in fact, here.
Would it be 7 pi fourths?
Okay, so 7 pi fourths was a suggestion, but why is it not? Let's ask that. 7 pi fourths is not in a quadrant where we have the inverse cotangent defined, right? Inverse cotangent will have to be, it's going to have to be in either the first or second quadrant, okay? One or the other. So because it's a negative value, it's going to be in that second quadrant, so it's going to be at the 3 pi fourths. Yeah, that's the only answer. Now, don't get that confused, because what else did we do in this chapter? We solved equations. We don't want to think, this is not an equation. This was just a question having to do with the inverse function. It is a little tricky. If you're just asked about the inverse function, you've got to think about where these things are defined. If you're asked to solve an equation from 0 to 2 pi, then we go on around, and then we would choose those other values as well, or value in this case. Anything else on that part? That's how we started. Then we did a little bit more with the inverse trig functions. We have the inverse tangent of the tangent of 2 pi thirds. Okay? The inverse tangent of the tangent of 2 pi thirds. Normally, what happens is if we have the inverse of the function or the function of the inverse, then our answer is just whatever the argument was there. Or in this case, that would be the 2 pi thirds. That can happen if it is located within the parameters set forth for the inverse tangent. What are the parameters set forth for the inverse tangent? Negative pi halves, positive pi halves is correct. So does 2 pi thirds fall within that interval?
No, it doesn't.
No, it doesn't. It's a little bit too big. So 2 pi thirds is maybe here. But from negative pi halves to positive pi halves, we want to look for an angle then that would have that same tangent. Okay?
Would it be negative pi thirds?
It's going to be negative pi thirds. Good. So that's what we're doing. We're coming down and we're saying what angle would have the same tangent as 2 pi thirds. It's going to have to be something in the fourth quadrant, because that's where our tangents are negative. If the tangent of 2 pi thirds, we know that's going to be a negative value because we're up in the second quadrant. We need a corresponding value where the tangent is also negative down in the fourth quadrant here. But this one we would call negative pi thirds. Any questions there? I'll give you a minute here. And let's do one that starts off with, I guess, one of the regular, so-called regular functions. Number 16 there, and the same part says the cosine of the inverse cosine of 0.6. This time, that parentheses part starting out saying what angle has 0.6 as its cosine, and then you want to take the cosine of that angle. So what we're looking at, though, we always look at the outermost function to give us our parameters that we're looking within. And on the inverse tangent up there on the first one, that was the outside function. So we had to look from negative pi halves to positive pi halves. But now on this one, cosine's the outside function. So if it's actually the trig function, we're looking at the range of their graphs, how far they go. What's that? Negative 1 to 1, right. Negative 1 to 1 is what we're looking within here for this part. So as long as that value is from negative 1 to 1, then that's going to be our answer here. Okay. And 0.6 is between negative 1 and 1. So we're good with that one. These are those redundant questions, kind of, because it's asking you to go in circles. It's based off the fact that f of f inverse or f inverse of f are both equal to the argument, or x. They are within the trig function. Any questions on either of these two? That was also maybe in the second section, first or second one. Mm-hmm. $17 cosine of the inverse.
Ma'am, we lost your content.
You lost my contact?
Content.
You lost my contact.
On the screen,
Oh.
yeah, we don't have.
You don't have the screen? Okay. It's still showing over here, so
Okay,
Rob,
we'll check it out then.
Rob. Okay, we'll get Rob on that one. They've lost my screen, Rob. I didn't do anything. All right. Tell me if you're getting it back over there. I'm just writing the problem. That's all right now. Okay, I'll go ahead and talk a minute. Y'all can still hear me, right? Can y'all hear me? But you can't see the screen. Still yet? No screen? Okay. Thank you. Yeah. Now I see those heads moving. That's good. So let me know. All right. So we're looking at number 17, if you have your book there on page 499. And what it's saying, here's what it's saying, okay? It says the cosine, actually it just says cosine. It does not say the. So it says cosine, and then it has a bracket. So write this down so you can see it, okay? Inverse cosine, parentheses, negative 0.3. What's that? The answer is just going to be negative 0.3 because, again here, the outer function was cosine. So whatever you get there, whatever your answer is going to be, it's going to have to be between negative 1 and 1. All right? And negative 0.3 is, so that would just be our answer. If the argument of the function is within the parameters, then that will be your answer. Was 19 the other one I heard? Yeah, okay. Do y'all have a screen back yet? No screen? Wow, that's interesting, isn't it?
No, I need to reboot the room. Can you give us a couple minutes?
Yeah, we'll take a little quick break then, okay? All right, if y'all need to go get a drink of water, go get you a drink of water, come back, okay? It'll be a quick break. They'll do this really fast. See, maybe it was meant for me to go to Kingsport today, wasn't it?
Now, we still have no screen, but we're back
No
in
screen.
communication with you.
What's that now? No screen, but what?
I mean, we're back in communication. We can see you and hear you, but we still have no screen.
Yeah, that's okay. Well, I wonder why. Do we know what's going on with that? I
No,
promise.
we'll try. I need to reboot one more time.
Okay. Okay, go ahead. Thanks, Rob. I see. Thanks. All right, they're going to reboot again. I'll try one more time here. Meanwhile, do y'all have some other questions that you know you're going to want to ask about? That you know you want me to work out? Anybody? I can go ahead and put those down. They can hear me too, so. I've got some picked, but. Do you know the answer to 19? Undefined, yeah, not defined. Why? Mm-hmm. It's because it's lower than -1. I'll have to tell them though too. So, but that's right. So if it's out of the range of -1 to 1, when it starts out with the trig function sine or cosine on the outermost part, then it's not defined. Okay. Now you're seeing, you remember it now.
So, like, what's the range on the cosine? Why would that be different than the range on the inverse cosine?
We're looking at two different things. If you've got the cosine on the outside, you're looking for the cosine of, okay, like in this case, it's saying the cosine of the angle that has -1.64 its cosine, right? Okay, but there is no angle that has -1.64 its cosine because all the values fall between -1 and 1. But if we go back over here, like on, never mind. I was going to say that when we look at the log, you probably get it down there, number 11. Then we're finding out, we look at the angle, we look at the tangent of 2 pi thirds, and then we say, what's the angle that has that tangent? So then we're looking for an angle. Does that make sense? Whereas on the others, we're looking for the value.
Okay.
So it's a difference. So if something starts out, I'll put it up here, but we can't see yet. If it starts out with the inverse cosine, then we're going to be between 0 and pi, because that's where the inverse cosine is defined. But if it starts out with cosine, we're going to be between -1 and 1. Okay? Difference in the functions that we're looking at there. If it's sine, it's still -1 to 1, right?
Tangent.
If it's tangent, it can be anywhere. Okay?
Because you're doing the y values.
Yeah, and that's what we're looking at, y values on that, what we can get out of that. Tangent's -infinity to infinity.
That makes a lot of sense.
Okay.
Okay, we're back.
We
good.
back?
We're
We
good.
good now? We
You
got
may
the
continue
screen?
teaching at will.
Okay, I'll do that then. Okay, we've got a few more minutes here to go. Okay, so let me go back on the screen here just a minute. Someone were talking about some of this over here, but we were out of touch there for a few minutes. So let's get back kind of together and connected here. On number 17 up there, so we were looking for the cosine of the angle that has a cosine of -0.3. Whenever we're looking at this, we want to focus on this outermost function, okay? So the outermost function here is cosine. So we're looking at values from -1 to 1 because of the cosine function itself, the range of the cosine function. You know, when we look at the cosine function, we go, you know, the wave, right? For the cosine function, the graph, it's from -1 up to 1. Same with if we had a sine function out there on the outside. Now the question came up over here while we were disconnected. Why, you know, is the cosine part and the inverse cosine different? It's because it's two different functions. So if we have cosine on the outside, we're going to go -1 to 1. If we have inverse cosine on the outside, we're going to go 0 to pi because we're talking about something else there. We're talking about which angle it would be. We're looking for an angle if it's an inverse function. If we have sine on the outside, sine's going to go then from -1 to 1 also. And tangent, if we have it on the outside, it's going to go where?
Negative infinity to infinity.
That's the one that's -infinity to infinity, okay? That sort of thing. But if we have inverse sine, then we're going to be looking from -pi halves to +pi halves. It is a lot of stuff to remember here in this part. Inverse tangent was -pi halves to +pi halves as well, but not including those boundary values, okay? Not including those endpoints. So back to number 19 up here. Number 19 said basically what it's saying. We start with this innermost part and we're saying what angle has a cosine of -1.6? We want to know then the cosine of that angle that has a cosine of -1.6. Normally in this case, you know, our answer is just going to be whatever the argument of the function is because we're asking a kind of roundabout question. We're saying, I want the cosine of the angle that has a cosine of -1.6. It's kind of repetitive, right? Okay, but the deal here is there's not an angle that has a cosine of -1.6 because the cosine only goes from -1 to 1. So it's out of the range. It's less than -1, so therefore this is not defined. Or undefined, however you want to say, okay? So that was those composite functions we were looking at. We had one other type of composite function as well. Let me get one of these down here. We had one like 22 in the review. On 22, we had the inverse cosine of the tangent of 3pi4. So this one, it's not just going to be the argument because we're not dealing with the function and its inverse, not the same ones, you know. So we've got to know here, what is the tangent of 3/4 pi?
1, or -1.
-1, right? -1, good. We know that because of knowing the unit circle, knowing those coordinates over at 3/4 pi. The inverse cosine of -1, that says what angle has a cosine of -1? What angle has a cosine of -1? It's pi, right. Good. Pi is the angle that has a cosine of -1. That's our answer there. Maybe that's better than the inverse cosine of the cosine. I don't know. All right. While we're talking about inverses, we also saw how to find the inverse of a function, how to write the inverse equation. So let's look at one of those down here. I'm looking at number 34, and if you want me to choose something different, you can let me know that. Okay. (34) says f of x equals the tangent of 2x plus 3 minus 1. We have -3/2 minus pi4 is less than x is less than -3/2 plus pi4. Okay, all that stuff to the right of the problem where it says x is between these values, that's giving me the domain of my function. There's a question kind of like this on your My Math Lab on one of the quizzes. Y'all remember that one? Some of you seen it? There's a question similar to this. Okay, so this is the domain of the function whenever they tell you where x can land, okay, where x can be, what it can be equal to. That's the domain of the function. Now, they want us to write the inverse function here. So to write the inverse function, remember we had some steps. To find the inverse, and you've got these somewhere else in your notes, but I'll put them up here. First thing we did was change f of x to y. So we've got y equals the tangent of 2x plus 3 minus 1. Then we switch the x and y's. So we'll have x equals the tangent of 2y plus 3 minus 1. And the last thing we did was whatever it takes to solve for y. Okay, whatever it takes there to solve for y on there. So we want to get that y by itself. We got to do a little bit of algebra here and do that. We're going to add 1. That gives me x plus 1 equals the tangent of 2y plus 3. I need to get that y out from that argument part, and it's part of the argument of the trig function, so I have to take the inverse trig function now. So I'm going to take the inverse tangent of both sides. So now that's going to give me the inverse tangent of x plus 1 equals 2y plus 3, because the inverse of the function, they undo each other. Okay? Essentially, that's what's happening. They undo each other and just leave us with that argument there. We want to get y by itself, so we've got to subtract 3. Now I have the inverse tangent of x plus 1 minus 3 is equal to 2y. And I'm going to have to divide everything by 2 to get y by itself, so I'll divide by 2. That's going to give me then the inverse function right there, because it's everything that's left on the left side here. There's not really much I can do with that. Whoa. That's equal to y, but once we solve for y, that is f inverse of x. Okay, once we solve for y, that is f inverse of x. Okay, so we're solving for y to find f inverse. Okay. Now, they might also ask you, they do ask you, on that quiz, they say, well, what's the range of that function that you started with? What's the range? Well, we're working with a tangent function here, and the range was from negative infinity to positive infinity, so that's the range that we want to use here as well. Range of f of x, negative infinity to positive infinity. Okay. And then they ask on the MyMathLab, the domain of the inverse. The domain of the inverse is the same as the range of the function. Remember, that was one of the properties of the inverse functions. The domains and ranges switch for a function and its inverse. So the domain of the inverse will be the same as the range of the function. So we just said the range will be that negative infinity to positive infinity. And the range of the inverse will be the same as the domain of the function. But on the quiz on MyMathLab, they're going to ask you to put it in interval notation. So instead of writing it like it is up there at the top, we're going to put it in parentheses since there was no or equal to symbol. We're going to have negative 3 halves minus pi fourths, comma, negative 3 halves plus pi fourths. The domains and ranges switch places. That's just one question on the MyMathLab thing right there, task all that. I'm not going to ask you for the domains and ranges, okay, just so you know. I might ask you to find an inverse function, but I'm not going to ask you that part. So if that's helpful for you to know that part, okay? But I know there's a question about that on the quiz. Okay. Let's look at how to verify one of those identities here in just a second. We'll establish an identity. Anything else on this one here? This was just the steps to find an inverse. You use those same steps no matter what the function is. Okay. Might have to use different algebra to get y by itself, though. Remember establishing an identity? Some of you didn't like that part so well, but here's the one I've got out of here. Sine theta cosecant theta minus sine squared theta minus cosine squared theta. No, it's equals cosine squared theta, sorry. Bad eyes this morning. So I've got sine theta cosecant theta minus sine squared theta equals, it's supposed to be equals cosine squared theta. We're trying to establish the identity. That meant show that the left side equals the right side. You can pick whichever side you want, but we start with the one that's most difficult looking and try to turn it into the other one through the use of identities that I'm not giving you on the test, the ones that you know up here. Okay? All right, so we're going to start the left side, and we're going to try to reach this cosine squared theta as our goal because we're starting with the left side because it's a little more involved than that right side. Okay? On the left then, I might say sine theta times 1 over sine theta. Change that cosecant to 1 over sine theta. We're looking for ways to get there, things to do to the left side. Actually, this one's not too bad because those are going to cancel, and I'm left with 1 minus sine squared theta. And one of my established identities is that sine squared theta plus cosine squared theta equals 1. So therefore, I know that 1 minus sine squared theta does equal cosine squared theta. Okay, so I've shown that the left side is equal to the right side. Remember, we did this through the use of identities. Tom?
What page was identity on one more time?
The identities that you have to know, well, those identities that you have to know, I don't know. Let's see what page they're on, okay? They're ones that we did back in the chapter 6, but they're also written on page 465. So you want to know the identities on page 465. Okay. It's good to note. Those are your quotient identities, reciprocal identities, Pythagorean, and even odd properties. Okay, those are the ones you want to have those up here. Most of them you probably do already. We've used them quite a bit. But that's what we use to establish identities, is those already known ones to help us get one side turned into the other. So we want to remember about those. Then we got into the equations actually next, even though they've got them kind of different in the review problems I see. But let me go over and do an equation over here, and then we can always come back to something if we have some time here. On number 113, over on page 501, okay, we have this equation to solve. 2 sine squared theta minus 3 sine theta plus 1 equals 0. We want to solve this equation from 0 to 2 pi. That's typically how they ask us to solve the equations. It's on that interval from 0 to 2 pi, including 0, but not including 2 pi. Okay. All right, so we've got then this equation. It looks quadratic in form. It looks like we're going to need to factor it. Let's factor it. My factors here, I've got to have something in the first spots in each parenthesis that multiply to give me 2 sine squared theta. So I have 2 sine theta times sine theta. And then in the last part of my parentheses, they have to multiply to give me that 1. It's going to be 1 times 1. Now, somehow remember my outer and inner products have to combine to give me that middle term of minus 3 sine theta. So how are they going to do that? What signs do I need to make them?
Both need to be negative.
They're both got to be negative, right? They both have to be negative because here on the outer product, I've got negative 2 sine theta now. If I multiply 2 sine theta times the negative 1, and then on the inner product, I have negative 1 times sine theta. That's negative sine theta. And together, a negative 1 sine theta and a negative 2 sine theta will give me that negative 3 sine theta that I needed up there in the problem. Okay. Another thing we notice, just to make sure, that last term had to be a plus 1. And if we've got this negative 1 times negative 1, we're going to get that plus 1. So that all works out. All right, so we set each factor equal to 0. And we're going to solve. So we're going to have 2 sine theta equals 1. So on this first one, sine theta equals 1/2. If the sine of the angle is equal to 1/2, now all angles where this happens from 0 to 2 pi, what am I looking at there? Where's the sine equal to 1/2? Pi 6. There's 1. Anywhere else?
5 pi 6.
5 pi 6. Okay. Anywhere else? Where? It would be negative 1/2 there, wouldn't it? The sign would be negative at 7 pi 6. Okay? So this is it for the where the sine's equal to 1/2. We just would have an angle up in the first and second quadrants there. Let's look at the other part of our equation here. The sine of theta is equal to 1. Where's the sine of theta? Equal to 1.
Pi halves.
At pi halves, right. So all those are our answers. Okay, we have 3 answers here. We've got all possible solutions from 0 to 2 pi that work in this equation that we were given. So when we solve an equation, we are looking in all 4 quadrants. When we're just asking a question like inverse sine of 1/2, we're only looking where inverse sine is defined. Okay? Anything else on this one? Now, I've already told you I'll give you those double and half angle formulas and sum and difference formulas, but we've looked at double and half angle earlier today. Let's look at one sum or difference formula here at least. See what we've got with that. I'm backing back up now to number, I don't know, let's see. We got 2 different types going on here. Let's see. We got 74 back there, where it tells us to find the tangent of 105 degrees. Now, this one, it doesn't tell us which formula to use, but probably I would first think, can I use something where I add values together or subtract values? And I think you can see probably pretty quickly that this is the same as 60 degrees plus 45 degrees, right? So it looks like it's going to be one of those types of formulas where we have tangent of alpha plus beta. And that was equal to tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. So that's what we're going to plug that into. Okay, we're going to let that be alpha and that be beta. So that we're going to have now, let's bring this down here. We kind of took a detour there. Tangent 60 degrees plus tangent 45 degrees over 1 minus tangent 60 degrees, tangent 45 degrees. Okay. So what's the tangent at 60 degrees? Just square root of 3, right? Yeah, just a reminder over here if you're forgetting there, at 60 degrees, the coordinates were what? 1/2 square root of 3 over 2. So the tangent square root of 3, right? Square root of 3 over 2 over 1/2. Plus the tangent of 45 degrees, That's 1. Good. 1 minus, and again, the tangent of 60 degrees times the tangent of 45 degrees. So we've got square root of 3 plus 1 over 1 minus square root of 3. Okay. That's not rationalized, but if you get that, that's okay. That's good. Okay. Well, that's what I'm saying. Even on the test, if you get it to there, that's okay. I'll take that, If you go ahead and rationalize it, you could go ahead and rationalize it by multiplying by the conjugate. We don't want to leave like fractions inside of fractions, if we don't have that here, but on some of the other things we've looked at, we have. We don't want to leave if there's just a single radical, nothing else in the denominator. Go ahead and rationalize those. But up on top here, we've got square root of 3. You should be able to rationalize, though, right? Plus 3, plus 1, plus square root of 3. I'm just saying if it's a matter of time issue, it could be. Don't worry with it on that. So it's 1 minus 3. So this is, what do we have there? 2 square root of 3 plus 4 over negative 2. That's going to be, we got to divide them all by negative 2. That's what it looks like is happening now. So we're going to have, basically we're factoring out a 2 on top. If you want to look at it that way. I've got negative square root of 3 plus 2, which is the same as negative square root of 3 minus 2. But, for time, I know some of you on this test, some of the problems really might take a little bit more time, okay? And I'm aware of that, so you can stop at that square root of 3 plus 1 over 1 minus square root of 3 if you want. So, go ahead.
How did you get the 2 square root of 3?
Oh, I took, the question is how did I get 2 square root of 3? And I've got square root of 3 plus square root of 3 is 2 square root of 3. Okay, because those are 1s in front of those. All right. Understood, right? Math that's understood. They always tell us that. All right, what else? What else on this one? This was an example of a sum or difference formula. It was the tangent one, but we also had, there's a lot of down there. I don't know if you all have tried these or not, starting with 81, where they give you the information, like the sine of alpha is this, the sine of beta is that, or something, like that. And they're asking you to find the sine, the cosine of the sum, the difference, the double and half angles. Now we're getting noises. Go ahead.
Can you do part A of 81?
Part A of 81. Let's go to that one then. 81A. To get us started on there. We have the sine of alpha is equal to 4/5. We know 0 is less than alpha is less than pi halves. That part's telling me what quadrant I'm in. That's what that's telling me. I'm in quadrant 1 on that one, okay? We also see the sine of beta is equal to 5/13. And beta is between pi halves and pi. So what quadrant's beta in? Second. And that helps if I'm going to draw and get my reference for what I'm working with. If we're working with the sine on part A, the sine of alpha plus beta, we're using the formula then that says sine alpha, cosine beta, plus cosine alpha, sine beta. You'll have that formula on a sheet, okay? You'll have that given to you. We already know the sine of alpha is 4/5, because that was given to us. We know the sine of beta is 5/13. Just for the record, that's what we know. We still have to find the cosine of alpha and beta in order to work this thing out. We're just filling in the missing pieces for the formula here. Okay, so let's draw the first one. Let's draw the first one there. It's in quadrant 1. We're going to have alpha. We know the sine is 4/5, so that tells me y is 4 and r is 5. And if y is 4 and r is 5, then I think we know that x is what? 3, right? So that means then that the cosine of alpha will be 3/5, x over r. So I'm going to put that up there. let's draw beta. Beta's over in quadrant 2. We're drawing a reference angle here for beta down here. The sine of beta is 5/13, so that says y is 5, r is 13. Oh, this one's a common Pythagorean triple also. What's x?
12.
It's got to be 12, but we're in the second quadrant, so it's got to be
Negative 12.
negative 12. Good. If in doubt, x squared plus y squared equals r squared. Okay. The cosine of beta is negative 12/13. So we would work this out. Let's come down here. We'll say equals. I've got negative 48 over 65 plus 15 over 65 is equal to negative 33 over 65. And that's the sine of alpha plus beta. That's what we do for these. Once you get that much worked out, you've got all the information really that you need for the other formulas as far as what you plug in, the cosine of alpha, cosine of beta, sine alpha, sine beta, whichever one you're working with. You can even find the tangent there, right? Study. Maybe go through and work some of those My Math Lab quizzes. You can go through quiz 7 now. I think it's 5, 6, and 7 that are on chapter 7, okay? If you have questions, send me an email. I'll answer you, okay? Anything else? Yes.
Jamie.
Yeah, I took care of 7 on 7. It's gone now. Yeah, okay. I'll go ahead. Yeah,
We'll take care of Cheyenne's makeup on Monday.
What's up? Okay,
makeup
hold on.
exam for Cheyenne. We'll take care of it here.
Finished. You guys are finished. If you have no more questions for me, y'all can leave, okay? All right. Yeah, she was talking about doing that on Monday. I can come over there if you're not going to be there, but I thought I'd check first and see if you were going to be there.
We will be here. We can take care of it.
Okay. Will you just keep a test over there then for her? And if you all want to work out that time, whatever works for you is great. Okay?
Yes. Okay.
Okay, so I don't want to put you out though, so that's why I was telling her I could come over there, you know, if you need me to. It's not a problem. Thank you for doing that, David.
Yeah.
What you got to do is the cosine of it, and then whatever you get from the cosine, then you get that.
Okay.
For the final answer, okay?
Thank you.
You're welcome.
Jamie, do you want us to send all the tests over at the same time, or the ones that?
Tuesday and Thursday.
If you could go ahead and send the ones from Thursday back to me, but
Okay,
then you just
cool.
keep one out though for Cheyenne, okay?
Gotcha.
Okay, thank you. I appreciate it.
I just need to sign this.
Yeah. Where you been?
I went to tutoring. Well,
I haven't seen you in a while.
I know.
Have I?
I've missed,
Right?
I think, 2 days of I went to tutoring though twice, and I feel like it took them 20 minutes to even figure out how to work it. And yeah, Chris, I and Thomas was one, and I specifically. Well, I think the Chris guy, the blonde hair guy, he was the one that took forever to figure out the problem. I'm going to meet with Thomas today and tomorrow, and.
Okay, that's great. That's
Yeah.
good. I'll give you a link to. Oh, you probably start recording.
Yeah, I got it.
So if you need to go back and review some of our notes or before you get this,
Yeah.
it'd be a good idea.
Oh, for sure do that. Do you all have office hours that you all do?
Yeah.
When is yours?
Mine is different.